All right, let's get right into it. We are literally diving deep underwater for this one to solve a mystery that's been bugging engineers for decades. And trust me, it has massive consequences for pretty much everything.
You know, deep beneath the waves, there's this constant battle going on. It's a war, really. A fight against crushing pressure and the salt water that just wants to eat everything away. And what's at stake in this war? Well, it's our most vital stuff. We're talking about offshore oil rigs, the pipelines that crisscross the ocean floor, even the foundations of our bridges. The stakes here are just insanely high. If one of these things fails, it's a catastrophe.
So, our best weapon in this fight is welding. Simple enough, right? But hold on. Welding is all about fire and intense heat. So how in the world are you supposed to fuse steel together when you're surrounded by the one thing on the planet designed to put out fire? Water. It sounds impossible.
And for decades, the answer was basically, you don't do it very well. Underwater welds were just famously, notoriously bad. They were weak, they were unreliable, and the biggest question was, why? The answer was a total mystery, locked inside this violent, super hot puddle of molten metal.
Okay, so let's get into the nitty-gritty. The technique is called underwater wet welding. Basically, a diver goes down with a special waterproof electrode. But that direct contact with the water, yeah, that's always been the big problem. It just kept creating these weak spots, right where you need things to be the absolute strongest.
And this is what goes wrong. Just look at that. It's a cross-section of a typical underwater weld. It's full of holes. These little pores make it look less like solid steel and more like a metal sponge. And every single one of those little gaps, that's a ticking time bomb, a potential spot for a catastrophic failure.
So, to crack this case, scientists had a huge hurdle to overcome first. They had to find a way to see what was happening inside that crazy molten puddle as it was happening.
I mean, really think about that. It's thousands of degrees hot, it's brighter than the sun, and it's all happening underwater inside a pool of liquid metal. How could you possibly see what's going on in there?
Well, here's their brilliant solution. They took a super powerful focused X-ray and paired it with a high-speed camera. And with this setup, they could basically see through everything. For the very first time, they could look right through the water, past that blindingly bright light, and stare directly into the heart of the molten steel. It's incredible.
And what they saw, well, it changed everything. It was the smoking gun. The culprit behind all these bad welds was something they'd kind of suspected but could never, ever prove. And it was bubbles.
Okay, look at this. This is the evidence right here. On the left, that's the X-ray of the weld pool underwater. On the right, that's a normal weld, done in the open air. The difference is just night and day, isn't it? That underwater one is a total mess, filled with these giant, dark blobs. And yep, those are our bubbles.
So let's break down what we're looking at. The water cools everything down fast, which is why the underwater pool is shorter and deeper. But the real drama is the gas. Underwater, tons of hydrogen gas boil out of the metal, and that's what makes these huge, wild bubbles. Compare that to welding onshore, where you just get a few tiny bubbles from the air. Totally different ballgame. And this time-lapse really shows you how violent it gets. We're not talking about gentle, champagne-like bubbles here. Oh no. These things form, they swell up, they merge together into bigger bubbles, and then they burst with some serious force. This constant churning just messes up the molten metal so it never has a chance to cool down and solidify the right way. Okay, so seeing the chaos is one thing, but this is science, right? To really prove that these bubbles were the problem, they had to measure it. They had to turn all that sloshing and bursting into cold, hard data.
And here's how they did it. They basically tracked the surface of the molten pool over time. You can think of these graphs like a seismograph for the weld. The top one, the underwater weld, looks like an earthquake, right? It's just wild peaks and valleys. That jagged line, that is the source of all the weakness. Now look at the bottom graph for the onshore weld. So much calmer. It's exactly what you want for a strong, solid bond.
So they put a number on that chaos. They calculated what they called an instability score. For a standard underwater weld, that score was 1.71. Remember that number. Now, what about the onshore weld? Its score was just 0.90. So yeah, that's a huge difference. The data was crystal clear. The underwater weld was almost twice as unstable. It proved what they saw.
All right, so mystery solved. The bubbles are the bad guys. But finding the problem is only half the battle. Could they actually fix it?
Knowing that big, violent bubbles were the issue, they had this beautifully simple idea. What if we could just make the bubbles smaller?
And their tool of choice was ultrasonic vibration. The idea is pretty cool. You basically hit the metal with a super high-frequency sound wave, way too high for us to hear, and it causes the whole thing to vibrate incredibly fast on a microscopic level.
And the effect? It's amazing. As those big, nasty bubbles start to form, these vibrations just shatter them into a million tiny, harmless microbubbles. It's like taking a violently boiling pot of water and turning it into a gentle, sparkling fizz. The whole molten pool just calms down.
But the real question is, did it work? Oh boy, did it. Just look at this data. Remember the bad underwater weld? Instability score of 1.71. The good onshore weld was 0.90. Well, get this. The underwater weld with the ultrasound came in at an incredible 0.50. They didn't just make it as good as an onshore weld, they made it better. It's actually more stable than welding on dry land. That is a game changer.
So, what does all this incredible science mean for the real world? It means we can stop patching things up with flawed welds and start building a genuinely stronger, safer future for all our underwater structures.
And here it is, the grand finale, the before and after. On the left, that's what we started with, the weak, spongy weld caused by all that bubble chaos. And on the right, that's the result with the ultrasound. It's solid, it's dense, it's strong. The mystery is solved, the case is closed.
You know, this whole thing is such a great reminder that sometimes the biggest, oldest problems aren't solved by trying harder, but by finding a whole new way to see the problem in the first place. It really makes you wonder, right? What other impossible challenges are out there, just waiting for us to invent the right camera to finally understand them?